In this video series, we're looking at comparing groups on a quantitative response variable. And we have started analyzing our data, first looking graphically at a comparison of the distributions of our three groups with the plain risk data. And then we calculated descriptive statistics to correspond to those side-by-side box plots, and additionally giving us the mean and standard deviation for each group. Now I want to turn my attention to modeling the scores as a function of groups and analyzing the effects, which in this case is just differences rather than true effects because this is not an experiment, and then the residuals. So let's go ahead back to our R notebook where we're doing descriptive analysis. Let me go ahead and add in a new code chunk here. And I'm going to start by creating a linear model, just as I did in previous videos in which we had a quantitative explanatory variable. Here is the function, linear model, LM, and I am modeling the response variable, which is quantitative, as a function of the explanatory variable, which is categorical, the different worldviews. Let me go ahead and run that. I'm saving this in model so you can see that it has appeared over here in my environment. If I click on this, I get all the different kinds of attributes of the model that I got when I did multiple linear regression before. Two of these that I'm particularly interested in are the residuals and the fitted values. Fitted values is the name that R gives for predicted values. So you remember in a linear model, for every value of the explanatory variable, we have a prediction. And the difference between that prediction and what we actually observed minus predicted, is the residual. Let's go ahead and calculate the predictions and the residuals for every single observation in our data. We have 225 of them. Let's go ahead and calculate that, and let's go ahead and add it to the data frame, and then we'll take a look. So I'm going to add in a couple lines here, and then I'm going to add in a couple functions. So now on line 41, I have a new variable that I'm going to add to my plain risk data frame called plain risk residual, and it's going to be the residuals that come from the model. And similarly, I'm going to add in a new variable, plain risk predicted, that will come from the fitted values or predicted values in the model. So let me run this, and now let's take a look at our data. So the very first individual in our data set had a score of 4 on the plain risk perception. Remember that these can range from 0 to 100. So 4 sounds to me like this person doesn't really view it much of a risk in order to, or when they're flying monthly, that's what they were supposed to imagine, the risk of taking a monthly airplane flight. So they do not consider it much of a risk. This happens to be a hierarchical list. And here's our predicted, 36.92. That is what we predicted. Well, their score was only 4. And if you take 4 and subtract from it the predicted, you get a negative 32.9, or about negative 33. What does that tell us? That tells us that their score was actually 33 less than what we predicted with our model. Notice the next person down, a score of 5.0. The predicted value for that person was about 25, and so they were about 20 less than what we predicted. The next one had a score of 1.0, also an egalitarian, just like the second person. And the prediction was about 25, and that means they were about 24 less than predicted. Wait a minute. 25 was the prediction for the third person and the second person. And as I scroll down here, as I scan the page, it's also 25 for the next one, the next one. All those egalitarians are 25. When I go down here to hierarchical list on line 13 and 14, they're the same as my first person. So you can quickly see that only 3 predictions have been made. A prediction for hierarchical list, a prediction for egalitarian, and a prediction for individualist. Why is that the case? Well, think about it. Multiple linear regression, for a specific value of the explanatory variable, we predict a value for the response. And if 2 people have the same value on the explanatory variable, we're going to predict the same response. In this case, we only have 3 different values for the explanatory variable. That is the 3 different worldviews. So therefore, only 3 unique predictions are going to appear in our data set, although the residuals could be different for every single person because we have different observations for each person, and a residual is the observed minus the predicted. Let's go back to our notebook and let's actually look at a plot. I normally wouldn't do this if I was creating a report, but for pedagogical reasons, I'm going to show you. And we're going to do a report at some point, so you'll see what I include from what I went over here in these lectures, what I include and what I don't include. The lectures include a lot of things that I will not include in the report because it's just to get you to understand. It's just for understanding purposes. What I want to do is I want to plot the predicted scores by the group. So here is the code that I've put in. This is the explanatory variable, worldview. So that's my X. It's going to be on the X line. My predicted is going to be the plain risk. I'm going to go ahead and set my Y limit from 0 to 100, which is indeed the limit of my scale. Then I have my labels for X, worldviews, my label for Y, perception of risk score, and then my main is going to be worldview and perception of risk. I also have this little PCH equals 19. That's optional. All of these are really optional, but that PCH equals 19 stands for pitch. It's telling me, or it's telling R, how big to make each of my points. And I set it that way on purpose for the kind of plot that we're drawing here. Let's go ahead and actually look at that plot, and that's what we get. So notice that all the individuals get the same prediction, all the hierarchical lists get the same prediction, all the egalitarians get the same prediction. If you look back up here at our side-by-side box plots, those lines here look very similar to these down here, but they are not the same. The lines up here, because these were side-by-side box plots, were medians. These are means. So here's the lesson. When we are looking at predicting a response variable from a grouping variable using a linear model, the prediction is going to be the mean of the group. So here we have the mean for each of the groups for every single person in that group. That is the only explanatory variable. So if you and I are in the same group and a researcher is going to predict our score, they're going to give us the same score. Now imagine if you and I are in the same group and what we're going to do is take a statistics test and the researcher gives us the same prediction score. You might say, wait a minute, why are you predicting the same score for the statistics instructor as you're predicting for me who I'm learning statistics? The answer is because the only explanatory variable in the model was the variable that put us in a group together. And so if that variable that put us in a group together was, for instance, our favorite color, we're going to get the same prediction even if the response variable is a statistics score. If you think that I should be given a different prediction than you on a statistics test, we would need to take into account something about experience with statistics or aptitude with statistics or number of years using statistics or something that is actually that extraneous variable that would be related to our statistics score. We would have to turn that into an explanatory variable. So the same sort of thing here. There might be lots of different reasons for people to have their perception of risk that they have, but this study is only focusing on their worldview as a reason for perception of risk. So everyone who is an individualist is going to have the same prediction unless we start adding other variables. Then we could start separating them out. Now let me go ahead and superimpose on this plot the actual values for each of the participants. We're looking here at the predicted values, and the prediction is going to be the same for everyone within a group, but their actual observed score, their actual observation, their actual perception of plane risk is not going to be the same for everyone in the group. Let's go ahead and look at that. So I've added in another function, points, and notice that I'm putting in a score. What the points will do is it will superimpose on the already existing plots some points, and I'm putting in the response variable score as our points, and I'm doing it based upon each group. So now we'll be able to see not only what we predicted, but what we actually observed, and there it is. So now you can see these points, which are represented in these box plots up here, where the box actually shows where the middle 50% of the points are. We're actually seeing them here individually as points, although admittedly, some individuals have the same points as others in their group, and so the points would fall right on top of one another, and we wouldn't be able to detect that there's more than one point there. We would have to put in some other kinds of commands if we wanted to separate those out. But this gives you the idea that we have a whole range of observed values in each of the groups, but the predicted value is the same for everyone that's within a group, although the predicted values are different from one group to another. Now those predicted values are individual means. Let me do one more thing here. Now I've added a command in which I've gone ahead and put in lines for the mean of the plane risk. Now, if you're looking at this command and saying, how is this going to put in a line and why do you have mean twice? Well, when you put in a line, you have to put the starting X and the starting Y and the ending X and the ending Y. Remember, X is horizontal, Y is vertical. So we're going to start at 0 over here on X, but we're going to start at the mean of the plane risk score on the Y. We're going to end at 4, which is going to be over here for the X, and we're going to end, 4 is going to be here horizontal, and then vertically, we're going to still stay at the mean. That will draw us one nice straight line. Here we go. There it is. So what you're looking at there is the mean score without paying any attention to the groups. So if you did not even know the 3 different groups, and I asked you to make a prediction, the best you'd be able to do is just find the mean of all the scores, and that would be your prediction. And that's represented here by that horizontal line that goes all the way across here. The fact that we know what groups they're in means that we would not make the same prediction for everyone. but we would only make 3 different predictions, one for each of the groups. Now, the difference between the grand mean that we see and the predicted value that we see is what we're explaining from group membership. If all 3 of these group lines were right on top of that main mean line, and the word that we actually use for the main mean is grand mean. So this line that goes all the way across is the grand mean. That is the mean of all the points put together. If each of these individual lines were on that grand mean line, we would say that group membership has no bearing on what individuals would perceive as risk of being on an airplane. But we do have some differences. We have individualist above the grand mean, hierarchicalist barely above the grand mean, and egalitarian below the grand mean. So at least in our sample, we don't know yet whether this is real convincing evidence that we will see any differences outside the sample, but at least right now in our sample, we are seeing some differences in those means. Remember also that when we were learning about multiple linear regression, and in fact, probably in your very first statistics course when you learned about simple linear regression, you learned about partitioning out deviation from the grand mean into 2 parts. One part is the explained part, one part is the unexplained or residual part. The explained part is when we take the prediction minus the grand mean. So the prediction for individualist is this line here that's only for individualists. The grand mean is the line that goes all the way across. That little difference, if we assign that little difference to every single observation, that would be the explained part for each of those observations. Notice here that the residual part would be their score minus what we predict. So if I take this point way up here at the top for this person that's an individualist, that big difference from here down to the line that is the mean for individualists, that difference of observed minus predicted is the unexplained. So the little gap between the 2 lines is the explained, and then the big difference up here would be the unexplained. Obviously, if we're talking about individuals who are close to these lines, then the gap isn't as big, and the unexplained might actually be smaller than the explained. Let me show you one additional way that we could look at this that might be useful to our understanding. I'm going to create another code chunk, and I'm going to put in some additional plotting functions, and then I'll tell you what they mean. I have added the function. We're going to do another plot. Let me go ahead and create the plot, and then we can talk about it. Notice what I did here in the plot command is that I put the predicted on the x-axis. Well, what is the predicted? Well, we know from up here, it's just the mean for each of the groups. So down here on the x-axis now are the means for each of the groups. So I've taken these lines and pretty much just tilted this whole graph on its side and put the means right here on the x-axis, whereas before we were looking at them on the y-axis. And then I plotted the residual along the y-axis. So this is a residual fit or residual predicted plot. And notice that I created lines using the mean of the residual. Well, if I use the mean of the residual, look what happens. The line goes right through 0. The mean of the residuals is always going to be 0. That's because we're looking at the deviations from the mean, and they counteract each other, the positive and negatives. When you sum them all up, you end up with 0. That's why when we calculate standard deviations and variances, we don't just sum up the deviations from the mean and then divide by the number of observations. We square in order to get rid of those negatives. Otherwise, we end up with 0 all the time. So the mean of the residuals is 0. And what we're looking at now is we're looking at the scatter of the residuals for each predicted value around that mean of 0. So if I look at this plot here, I see the residuals for the first group, which was actually not the first group, the group that had the lowest mean, and that was the egalitarian. So this is the egalitarian group. And then the next lowest mean was the hierarchical list. So that's this group over here, around 37. And then we had the individualist group was the last one. I note that the spread of the residuals is very similar amongst each of those groups. And if it looks like there's more positive residuals here for the egalitarian group, notice that there's a lot of thickness here. There's a lot of darkness here in these dots. So there's probably about as many below the 0 here as there are above the 0. It's just that above the 0, they tend to be spread out more. These values tend to be spread out. If we go back to our original box plot, you see here how we come from the median and go way up to the top, but the median itself, these values are really compressed down here. So when I end up taking the residual, which remember is observed minus predicted, these are the values that I get for all the members in each of these groups. Okay, we've looked at some interesting plots. We've looked at the points on the plots. We haven't actually looked at our regression model yet, so I'll do that in the next video.